All right, so we're on 21. In this section, we are given the description of the transformations and asked to write the equation. Okay, so as a reminder, let me tell y'all real quick. The format of your equations, remember, you can have D at the end. D could technically be written at the beginning in front of the plus or minus A if you wanted to. Your B can be factored out, or the B could be in the parentheses, multiplied in. And when that's the case, you have this C value, and you have to calculate your horizontal shift by doing negative C divided by absolute value of B. Okay, so this is actually a formula chart that we put together, and you're going to get to use this. You will have this on the test tomorrow. So it has the format of the equation with what the A, D, C, and B are used for. Okay, reminder that your period's 2 pi divided by B, your B's 2 pi divided by the period, depending which direction you're needing to go. Okay, and it has one sine cycle and one cosine cycle with those critical points, those critical angles. You do need to understand and remember that negative sine or negative cosine would be the reflection of these, right? Negative cosine would go low to low instead of high to high, right? And negative sine would still start in the middle, but it'd go down first and then up and back to the middle. Okay, but this information you will have like on a formula sheet tomorrow. All right, so keeping that in mind, I need to understand that if something is vertically stretched or compressed, that is the A value. That's changing the amplitude, right? Do y'all agree? So if it is vertically compressed by 3, that means vertically we're squishing it down to a third of its size, a third of its height. What does that mean A would be? 1/3. Good. Okay, if it is shifted to the right, so shifting left or right, that's a horizontal. I'm using the wrong color here. I'm trying to keep everything color coded the right way for the whole review. So let me switch my color. Okay, shifted left or right is a horizontal shift or a phase shift that is affecting, I'm going to write that as HS because in the equation I have it labeled as HS. Okay, so if it's to the right, that's a positive pi halves for the horizontal shift. Now, when that gets plugged into the equation, and they tell us to do this one in terms of sine. So A is 1/3 sine, and then your B, they didn't tell us anything about a horizontal stretch or compression. So B remains an understood 1. Okay, so nothing has to be written there. And then your horizontal shift, remember, it's the opposite. So it's going to be minus pi halves. Bless you. Okay, and then there is no vertical shift. So the D value is an understood 0. So nothing written at the end outside the parentheses. Does that make sense? Okay, let's try it here. We're going to use cosine. We said a vertical stretch or compression is your A value. It's affecting your amplitude. So if it's vertically stretched by 4, that means we're pulling it 4 times its height. What is A? 4. Okay, it's shifted down. So this is a vertical shift. So that is your D value. And it's down, so it is, negative 12. Okay, that means your midline would be at negative 12. Okay, and then it's shifted right, pi. We said shifting left or right is your horizontal shift. So to the right is positive. So the horizontal shift is pi, but when that gets plugged into the equation, it's written as the opposite. So it'll be minus pi. So your A is 4. We're writing this as cosine. Nothing about a horizontal stretch or compression. So again, B is an understood 1. Horizontal shift, we're going to write minus pi. And then vertical shift down 12. So minus 12 is outside the parentheses. Or that D could be at the beginning. So you could start with negative D, and then this is positive cosine. So you'd write plus 4 cosine of x minus pi. Okay, so that minus 12 can be at the beginning or the end. Both of those are correct. Good? All right. Let's try 23. This one is sine horizontally compressed. So that's new. We haven't had one that's a horizontal stretch or compression yet. Horizontally, that's left and right. Compressed by 5, that means you're squishing it in. Like, so it's going to be a fifth of the width. You're squishing it in 5, so you could fit 5 and where it normally goes. Does that make sense? So what would your B value be? 5, because horizontal compression and stretch, remember, is the opposite of what you think. You think, oh, well, it's being compressed, it's getting smaller, this should be 1/5. But when we're doing the horizontal, remember, it's the opposite. Okay? If it was horizontally stretched by 5, then B would be 1/5. Does that make sense? Kind of, sort of? Okay. So our B is 5. Now this one is reflected over the x-axis. So that means that my sine is going to get a negative in front of it. And we're going to flip the graph. So that's the only change is the B. So A is an understood 1, which I don't have to write. I'll just write negative sine. B is the 5. And then there's no horizontal or vertical shift. So I don't have to have plus or minus anything in parentheses or out of parentheses. So that's as far as I take it. Good? All right, so the last part of this review is sketching the other trig function, the ones that are not the sinusoidal wave. Okay, so this is tangent and cotangent, cosecant and secant. Okay, so I'm going to actually start, I'm going to go in the order that we learned them in and start with cosecant. What is cosecant the reciprocal of? Sine. Okay, so very lightly, and you can do this as a dashed line or whatever you wanted, I am going to sketch a sine graph. Okay, so 2 pi is 1 full cycle. So if we go up to 1, 3, 0, down to -1, that's the sine graph. Cosecant is the reciprocal. So that means I'm taking these curves, these two curves where they're curving into each other and meeting, and I'm going to flip them away. I'm still going to have the maximum and minimum points. Those are still on it, but it's going to flip out. So the curve is going to open this way, away from each other, rather than toward each other. And where they used to meet for sine, these are never going to meet. In between these are asymptotes. So all those places where sine touched the x-axis, those are asymptotes. Okay. Secant is the reciprocal of what? Cosine. So I'm going to sketch real quick. Cosine starts high, comes low, ends high. So this is the cosine curve. So secant is the same thing that happened here. Instead of facing each other, these curves are facing out. They're flipped over. Now this would continue over here. We just don't see it. Same thing. This would continue on the negative side. Okay. And wherever this was touching the x-axis, there are asymptotes. Okay. So they're pretty similar. Just remember, cosecant has an asymptote on the y-axis. Secant has a curve on the y-axis. Okay, it's just, they've just been shifted over from each other. Okay, now before I jump into tangent and cotangent, does anybody remember the differences in tangent and cotangent from each other? Okay, one's increasing and one's decreasing left to right. Which is which? Yeah, tangent increases. Tangent is the one that shaped curves go like this, left to right, increasing. Cotangents are decreasing. What's the other difference between them? Besides the direction of the curve? Yeah, where those asymptotes show up. Okay, so if you forget and you don't remember, you hopefully will remember that tangent is sine divided by cosine, right? So where sine is 0, tangent is 0. So bless you. So where sine crosses you can see the sine is the real thin one I drew there. Where it crosses the x-axis, okay, tangent is going to cross the x-axis. So that's here at 0, at pi, and at pi halves. Those are going to be points on the tangent graph. So in between those is where the asymptotes are going to be. And we said that tangent increases left to right. Okay, cotangent is the opposite direction. It's decreasing left to right. And the asymptotes are at different places because cotangent, you flip it, it's cosine over sine. So when cosine has a 0, which is at pi halves and 3 pi halves, that's where this one's going to cross, and the asymptotes are between. So it's the asymptotes and the zeros which spots, and this one is decreasing left to right. Okay, so you've just got to be able to know the difference in those that are not the sinusoids, but you can use what you know about sine and cosine to help you sketch those. Okay, again, you're not going to be asked to sketch them, but you'll be asked questions about the graphs. Remember, cosecant and secant, they both still have a period of 2 pi. It takes 2 pi before the graph starts repeating itself because these are alternating up, down, right? So you have to go through 2 of those. You have to pass one of the asymptotes before it starts repeating. But with tangent and cotangent, between every asymptote is the exact same curve. It doesn't like switch direction or anything. So remember, the period for these two is only 1 pi. as opposed to the 2 pi of all the others. Y'all feel okay about this? All right, so that's it. That's all the review. This was the third class period today. This is the third video. So I'm going to stop the recording here. But if there's something that you didn't get help on, there's a question that you still have, the key is going to be posted. All 3 of these videos are going to be posted. So you can go back to a different video to get help on a different problem if you're stuck somewhere.